innovations for a sustainable future at Wagh Institute of Engineering, Education and Research, Nashik. Today, we have an excellent lineup of speakers and technical sessions focusing on cutting-edge developments and sustainable engineering practices. We encourage you to actively participate, engage with the speakers, and connect with like-minded professionals. Let's embark on day 2 with enthusiasm, expand our horizons, and leave inspired to drive the future of sustainable engineering. Thank you, and let's make today truly impactful. Now, I request my colleague, Ms. Priyadarshini, to introduce our eminent speaker, Dr. Lalith Liyanage.
Thank you, Merin. Good morning to one and all. I'm feeling very much privileged to introduce our esteemed guest, Dr. Lalith Liyanage. Dr. Lalith Liyanage is a distinguished professional currently serving as a CEO and General Manager of Ceylon Fisheries Corporation, Sri Lanka. He has held several key leadership roles, including Project Director of Secondary Education Sector Improvement Project, Chairman of Ceylon Petroleum Storage Terminals Limited, and CEO of Ministry of Defense Procurement and Project Company. Additionally, Dr. Liyanage is an accomplished academic lecturing at University of Marathwada, Sri Lanka's top engineering university, and previously at Northumbria University, UK. His educational qualification include bachelor's and master's degree in electrical engineering from the USSR, a master's in computer studies from the University of Essex, UK, and MBA in e-governance from the University of Marathwada, and PhD in online learning from Northumbria University. Dr. Liyanage is a chartered engineer and recognized for his contribution to research and computer security. He won the Cisco Award in Sri Lanka in 2013. In addition to his professional and academic achievement, Dr. Liyanage is a passionate sportsman. Liyanage is a passionate sportsman, excellent in several sports, and has represented Sri Lanka in hockey and football. He also holds an advanced diploma in sports management from the International Olympic Committee and served as president of the Table Tennis Association of Sri Lanka. His career reflects a blend of leadership, expertise, and commitment to both profession and sports. We are very honored to have you with us, sir. Now, I request our guest, Dr. Lalith Liyanage, to share his views on engineering innovations powering a more sustainable future.
Okay, thank you for the kind introduction. Very good morning to the eminent audience in front of me. And it is indeed an honor. Let me first share my slides. I hope you can see my slides.
Yes, sir. Yes, sir.
Okay, and I am audible.
Yes, sir. Please continue.
Okay, right. So, namaste and ayubowan. It is indeed an honor and privilege to have been invited to do a keynote at this prestigious international engineering conference. Let me say a big thank you to my good friend, Professor Ravi Munhe, and the organizing committee of the conference for inviting me. I apologize for not being able to be with you physically due to my long year-end travel until last Sunday. So as per the introduction, you can see my profile on the screen. And I must highlight that I am the Sri Lanka representative of Institute of Engineering and Technology South Asia Committee, and also an international professional registration advisor for the IET UK. So this is the brief agenda. I will be talking with you for the next hour or so. You can see the first agenda point as Ramayana, epic poem. I can see the audience is very young, girls and boys. You might have heard, might not have heard about Ramayana. Let me relate it to this conference as well. And then I will be talking about sustainable engineering. And then my main conference theme, latest engineering innovations powering a more sustainable future. Because the conference main theme is sustainability. And then if time permits, we will have a small Q&A session. So why Ramayana is significant to my speech? There are 4 important points. Number 1, the relationship between India and Sri Lanka in this Rama Ravana story. And then number 2, the mention of aeronautical engineering in the story. Number 3, this conference is held in Nashik, where God Rama and Sita are mostly related to. And number 4, me being at Nashik. You can see on the screen photographs of myself with Professor Ravi having Panapuri at the bank of the Godavari River and some of the temples. Let me tell you what are the important places in city of Nashik related to Ramayana epic poem. So you will see, if you have not visited, I recommend you to go and visit Godavari River, Panchavati Temple Complex, and then Rampur water tank where Lord Rama was thought to have bathed, Sri Kalaram Sansthan Mandir, where which is an ancient shrine to Rama, and Sita Guha caves. Rama and Sita are said to have worshipped that. So you can see I have been able to, thanks to Professor Ravi, he took us in his car and we were able to visit all these places, which are very important for us as well. So that's why I selected to spend about 10 minutes about Ramayana story. We consider Ravana as an unlikely pioneer in aviation. Is he? We'll see. Ravana is a legendary figure who looms large in Sri Lankan and Indian folklore. There is no archaeological evidence, though, to show that King Ravana existed. Nevertheless, several Puranic texts, including the Hindu epics, Ramayana and Mahabharata, you all are well aware of, claim that he was real and not just a mythical figure. These texts contain descriptions of the legendary aircraft that he used to travel within Sri Lanka and to other kingdoms across the ocean. This is obviously much before than 1903 Wilbur and Orville Wright's invention of aircraft, which you very well know. Ravana was famed to have owned many flying vehicles for air travel. Ravana is believed to have manufactured an aircraft called Dandu Monara, known as Pushpaka Vimana in India. He had used the aircraft to fly to India and several other places overseas. In Sri Lanka mythology, these aircraft are called Vimana. In Sanskrit, the word Vimana is composed of V, the sky, and Man, measure. Ramayana in Lanka says that the term Vimana was used to refer to airborne chariots that traverse long distances through the skies. The book goes on to mention that the Vaimanika Shastra, an ancient Sanskrit text on aeronautics, speaks about the construction of these chariots. And story continues. Ramayana in Lanka says that the corroboration for the famous Vimana and airports of Ravana comes in the form of many technical treatises in Sanskrit on aircraft technology, with Vaimanika Shastra being one of the most prominent of the technical treatises. The text describes the design of a few aircraft and discusses the fuel, mechanisms, and maneuvers of the same. According to Ramayana in Lanka, Ravana took hostage Sita, the wife of the Hindu god Rama, and brought her to his kingdom in an aircraft called Pushpaka Vimana. As the story goes, Rama followed Ravana to Lanka to reclaim his wife in an epic battle. After defeating the demon king, Rama used the Pushpaka Vimana to return to the kingdom of Ayodhya with his wife Sita. As you all know, Ayodhya is famed as the birthplace of Lord Rama. In modern day Sinhalese, the word Pushpa translates to flower. So the name Pushpaka Vimana literally means an aircraft shaped like a flower. According to Ramayana in Lanka, the Pushpaka Vimana had a special capability of expanding or contracting in size in accordance with the number of passengers. So this is the story in brief about Rama Ravana. And when I was preparing for this keynote address, I accidentally found this branding trailer developed by our national carrier, the Sri Lankan Airlines, which is exactly aligning with what I have just told you. So I would prefer if you see this video and get the better idea of what I have just told. Let me do the technical settings for the video from this end, and please bear with me for a minute.
In the Ramayana.
Can you see the video and the audio, please?
Yes, yes.
Okay, right. Please enjoy the video.
And now, beta, Lord Rama has to rescue Sita from Lanka.
What's Lanka, Daddy?
Lanka was Ravana's kingdom.
Is it a real place, Daddy?
Yes, of course, beta. All the places in the Ramayana are real. Today, we know Lanka as Sri Lanka. And then, Ravana flies with Sita to Lanka in his Pushpaka Vimana.
Where did Ravana keep Sita, Daddy?
He first kept her hidden in a cave. And later, kept her in a beautiful garden in his palace.
How did Lord Rama know where Sita was?
Hanuman flew to Lanka and found her in Ravana's palace. She was praying to Lord Rama to come and rescue her.
But didn't Ravana's people catch Hanuman?
Yes, they caught him and tied him up and set his tail on fire. But he jumped from building to building and set the palace on fire.
How did Lord Rama reach Lanka? Did he also fly, Daddy?
No, beta. Hanuman and his army of monkeys and bears built a bridge from India to Lanka with rocks, boulders and trees.
Oh, is the bridge still standing?
Yes, you can see it even today. It is called the Ram Setu Bridge. When Lakshmana got injured and was about to die, they quickly wanted a magic medicine from the Himalayas. When Hanuman reached the Himalayas, he didn't know which plant to get. So he lifted the entire mountain and flew with it to Lanka.
Whoa!
On the way, some parts of the mountain fell in some places.
But Daddy, how do you know this is where Hanuman dropped it?
Because Sanjeevani Parvata, where the magic plant grows, is only found in the Himalayas and now in Brahmasala too. And this is where Lord Rama launched the powerful Brahmastram arrow that killed Ravana.
What did Lord Rama do after that, Daddy?
He was sorry for killing a Brahmin who Ravana was. So he built a second Shivlingam in a temple where Ravana used to meditate to Lord Shiva for long hours.
Then what happened to Lanka?
Lord Rama crowned Ravana's good brother Vibhishana as king of Lanka before returning to Ayodhya.
Daddy, I love this Ramayana story. Can we go to Sri Lanka and see these places?
Of course, beta. Your father is taking us all on the Ramayana trail this year.
Daddy, I'll pluck that magic herb and plant it in our balcony.
I hope you all have enjoyed the video I will show you, and also you have a better idea of this Rama Ravana story like that small boy in the video. So let me now shift back to the main topic. Let me share the slides back. Yeah. Share. Okay, so I think I am audible and visible.
Yes, yes.
Okay, right. Thank you. So let me now shift from mythology to reality in engineering. This is what the greatest scientist or greatest intellectual believed to have lived in the world had to say about engineers. Scientists investigate that which already is. Engineers create that which has never been. So we all as engineers must make sure that we stand by with what great Einstein said. Having said that, let us move to the first topic of my presentation, which is what is sustainable engineering? Because the conference theme is sustainability, and we as engineers, we should know clear that what is sustainable engineering. Sustainable engineering is a way of designing and creating things that meet our needs without harming the environment. Most important word, without harming the environment or depleting natural resources. So we had so far, I think in front of me, students doing electrical, electronics, mechanical, civil, automobile, software, hardware, etc. So we all know about these engineers. But now a new designation has come out called sustainability engineer. What does a sustainability engineer do? The primary goal of a sustainable engineer is to design and implement engineering solutions that minimize negative impacts on the environment. The key responsibilities of a sustainable engineer include environmental protection, which is design and implement engineering solutions that minimize waste, pollution, and resource usage to have a lower impact on the planet. And number two, corporate social responsibility, CSR. Assist businesses in improving their sustainability performance by implementing sustainable practices and technologies. And then collaboration, which is very important. We engineers work with architects, urban planners, policymakers, and other professionals to promote sustainable practices in various engineering and construction projects. And number four is waste management. Each and every country faces this problem of waste. So how we manage waste? I have a special separate topic also. And in broader terms, develop waste management systems to reduce, recycle, and properly dispose of waste generated by industrial processes and communities. And finally, we have sustainable materials. What are the sustainable materials? So we have to seek out and utilize environmentally friendly and recyclable materials for construction and engineering projects. So this is the responsibility of sustainability engineers. And as the effects of climate change, so all these have been extensively talked about because of the climate change we have been experiencing during last decades. So this, due to this climate change, it has become more apparent, and increasing number of students have pursued their interest in the subject in higher education, with universities around the world increasing number of sustainability related degrees. This is how, when you do a sustainability related degree, you will have a job in the market. So there are a number of sustainability engineering jobs. Number one is sustainability consultant. Sustainability consultants assist businesses and organizations in implementing sustainable practices and minimizing their impact on the environment. So that's his responsibility. So they provide guidance and recommendations on how to reduce energy consumption, produce less necessary waste, and promote eco-friendly initiatives. And we have renewable energy engineers. So we talk a lot about renewable sources today, and there are specific engineers who are working on renewable energy. So they specialize in the designing and creating renewable energy systems. They focus on developing technologies such as the main two renewable technologies are wind turbines and solar panels that use clean and renewable sources of energy to generate electricity. And then we have environmental engineers. So because we do everything to protect the environment. So there are special designations as environmental engineers. But they do, environmental engineers work on various projects related to controlling water and air pollution, managing waste, and repairing environmental damage. They develop strategies and solutions to address environmental challenges and ensure compliance with regulations to protect ecosystems and human health. And we have then sustainable transportation engine, because transportation is a very big source for the gas house emissions. So sustainable transportation engineers are involved in the development of transportation systems that prioritize environmental sustainability. They focus on designing and implementing initiatives such as electric vehicles, public transport, and bike infrastructure to reduce carbon emissions and promote environmentally friendly modes of transportation. And then we have sustainable agriculture engineering. Now, agriculture is another area which is in the focus at the moment. So sustainable agriculture engineers focus on developing practices and technologies that promote sustainable farming. They work to minimize the environmental impact of agricultural activities, conserve natural resources, and enhance food production through organic farming, water conservation, and efficient resource management. And finally, we have energy efficient engineers. So what energy engineers do is they work to improve energy efficiency in buildings, manufacturing processes, and transportation systems. They analyze energy consumption patterns, identify areas of inefficiency, and implement measures to reduce energy waste, lower operating costs, and lessen environmental impact. Okay, now I guess you have the idea of what is sustainable engineering, what are the responsibilities of sustainable engineers, and what is the sustainability engineering, what are the sustainability engineering jobs we have. Now, this is the main area of my keynote. So I have selected 10 most eminent technologies available at the moment, which are innovative and powering a more sustainable future. So you can see sustainable aviation propulsion, clean energy technologies, sustainable mobility and transport solutions, smart cities and sustainable infrastructure, waste management and circular economy, agriculture and food security innovations, smart grids and IoT for sustainability, carbon capture, utilization, and storage, and then water purification and management, biotechnology and green chemistry. So if time permits, I will have some information about role of Indian engineers in leading global sustainability. So this is what in the next hour I will be talking about. I hope so far you are with me, and let us go to the first topic, which is sustainable aviation propulsion. Because I thought of starting off with the aviation sustainability, having talked much about Ravana's Nadumonara and Pushpaka Viman. So the future of flight is electric, with integrated propulsion systems that make aviation safer, quieter, more efficient, and greener. There is a need to design and develop a broad range of state-of-the-art solutions across the entire propulsion system, which consists of propulsion, auxiliary power, power generation, and power controls, including turbo generators necessary to turn mechanical power into electricity. Power distribution to move high voltages throughout the aircraft and deliver it to electric propulsion units, the EPU. The EPU then converts electricity into mechanical power, which turns fans and rotors and allows propulsion. In today's context, megawatt class turbo generators are in operation. In addition to conventional jet fuel and diesel, this product is able to run on aviation biofuel or green jet fuel, which is chemically similar to fossil fuel but made from more sustainable alternatives. As battery technology matures, electric and hybrid electric aircraft can also use a combination of batteries and fuel cells to power the aircraft. Hydrogen fuel cells are the latest addition to the growing portfolio of power systems that improve the safety and efficiency of aircraft. The proton exchange membrane fuel cells run up to 3 times longer than equivalent batteries and are 5 times more reliable than small engines. They work silently and emit no greenhouse gases. And unlike batteries that need to be recharged, hydrogen fuel cells can be refueled in seconds. So this is what sustainable aviation propulsion is about. And I want to talk about sustainable technologies for civil aviation. So there are 3 main areas I will be talking about. The aviation and air travel industry is now focused on developing more sustainable alternatives to conventional aircraft. 3 promising options, as I said. Each option can reduce fuel consumption and emissions while facing with unique challenges requiring a reimagining of aircraft design and operational standards and a full evaluation of their environmental impact. So let us take one by one very briefly. All electric aircraft. Due to the range limitation with battery-powered electric propulsion and various challenges with hydrogen-powered aircraft, environmentally friendly short-range commuter aircraft are likely to be the first types of sustainable civil aircraft to enter into service. It is likely that the first all-electric powered aircraft will be propeller aircraft, with electric motors replacing the power plant. And next one is hybrid electric aircraft. So we all know, even in motor cars, we have diesel petrol cars, hybrid cars, and electric cars. So similarly, engineers are working on civil aviation similarly. So what is hybrid electric aircraft? For the replacement of medium range aircraft, such as the A320 and Boeing 737, it is likely that hybrid electric aircraft propulsion will come first, followed by hydrogen-powered turbofans for the replacement of long-range aircraft. The downside to hybrid electric propulsion is the need to burn fuel to generate electricity, either to directly power the electric motor and no charge the batteries. Changing the energy source from one to another tends to be inefficient. Plus, there is the added weight penalty of carrying the auxiliary power unit, APU. So this is about hybrid electric aircraft. And then we have finally hydrogen electric fuel cells. A fuel cell is an electrochemical device that converts hydrogen directly into electricity and heat with none of the byproducts of combustion, such as carbon dioxide. Apart from heat, water is the only exhaust produced by a fuel cell. For takeoff and climb, a combination of battery and fuel cell is used to power the electric motor connected to the propeller. Once above 3,000 feet, the batteries are disconnected and level flight is maintained using only fuel cells to provide power to the electric motor. It is envisioned that this technology has the potential to power small manned or unmanned air vehicles for survey. So this is about how civil aviation and aircraft engineering is moving from conventional fuel to sustainable fuel and other technologies. So let me move into our second area, which is clean energy technologies. So entire world is concerned about now the clean energy technologies. So there are 4 main areas: solar power, wind energy, energy storage solutions, and hydrogen energy. We'll take one by one very briefly. So what is solar power advancements? The development of more efficient solar cells, obviously, such as you all know perovskite thin film solar cells, and also bifacial photovoltaic solar cells, the 2 main types of solar cells. Is increasing energy capture and reducing the cost of solar energy. I mentioned previously about sustainable energy engineers. So it's their responsibility to work on these areas. And then wind energy innovations. Offshore wind turbines are being designed to capture strong and more consistent winds at sea, while floating wind turbines are expanding possibilities in deeper waters. And then energy storage solution. Breakthroughs in battery technology like solid-state batteries and new lithium-ion chemistries are making renewable energy more reliable by enabling efficient storage for use when demand is high or sunlight or wind is unavailable. So although the maintenance of batteries are costly, still we need it when the sunlight or wind is absent. And finally, we have hydrogen energy. This is the latest addition. Green hydrogen production through electrolysis powered by renewable energy is gaining traction as a potential carbon-free fuel for industries like transportation and heavy manufacturing. And there are some technologies powering clean energy transition. Let me take you through in detail. So what is a smart grid? Smart grids are electricity transmission and distribution networks upgraded with digital technology to better manage the flow of electricity from generation to consumption. With help of smart meters and latest communication infrastructure, they balance fluctuating demand from consumers with intermittent supply from renewable sources. We all know how the analog systems worked previously, and now with the extensive renewable energy supplied by the individual power generations like solar power, overhead solar, etc., it's very difficult to manage the utility companies to manage the load balance. Then about batteries. Battery energy storage systems are essential to the energy transition. They store solar and wind power for later dispatch, as I earlier mentioned, to meet peak load demand and can be used to compensate quickly when there are sudden dips or surges in electricity supply. And then electric vehicles. An estimated 97% of, you will not believe, estimated 97% of all electric vehicles worldwide are in Asia Pacific. And around 98% of electric buses in the world can be found in the Asia Pacific region. Approximately 80% of greenhouse gas emissions from transport sector, however, come from freight movement, primarily in the maritime sector. So this is a major concern. And then we have green hydrogen. I briefly touched this in the previous slide, has potential to decarbonize specific sectors used as an alternative to fossil fuels in powering vehicles, marine vessels, and in industries such as steel and iron production, and to store renewable energy. But most of the world's hydrogen is currently produced using natural gas or coal. This is the problem. So to be an effective decarbonization tool, hydrogen must be green, extracted from water using electricity from renewable sources. Otherwise, it is of no use talking about green hydrogen. And then we have the new concept of green buildings. Buildings and construction sectors emit about 38% of global greenhouse gas emissions. Around 35% of total energy consumption also comes from these sectors. They are highly energy efficient, having constructed using sustainable materials such as green steel, hence highly water efficient, and they factor in proper waste management. And we have finally electric cooking. In Asia Pacific, about 1.2 billion people lack access to clean cooking facilities in 2020, and they still cook with biomass, charcoal, and kerosene, and are exposed to dangerous levels of indoor air pollution. For example, I have solar panels on my rooftop, and entire my house cooking is happening on electric hob. So this is what you should be contributing to the environment. And we will move into the third area of my presentation, which is sustainable mobility and transport solutions. So we have a couple of areas. Some have already been covered in my previous slides, like electric vehicles, battery technology, and let me touch upon wireless electric vehicle charging. Research into inductive wireless charging systems would eliminate the need for physical connectors, reducing wear on charging ports and making charging more accessible. And smart charging networks. I will talk about this later with Elon Musk, the Tesla example. But yeah, let me take it later. And then public transport electrification. So innovations in electric buses and trains, that will also be covered later in the in another example of London bus system. These are the examples which I just mentioned. So these are the popular commercial green transport solutions being used by the world giant companies. So number one, you all know the top innovative solution provider of the world today, I think Elon Musk. So he has electric vehicles and electric vehicle infrastructure, the Tesla supercharger network. What it does is it has been at the forefront of the electric vehicle production, but also developing a comprehensive charging infrastructure to support them. These chargers can provide up to 200 miles of range in just 15 minutes, addressing one of the primary concerns about electric vehicles, long charging times. When the electric vehicles came into market initially, it was, I mean, maximum, I can remember the car brand I wouldn't want to mention, but only 180 kilometers could be done at one charge, which took up more than 3 hours. So now Elon Musk has kind of addressed that issue. So they estimate that its supercharger network has enabled more than 10 billion electric miles of driving, potentially saving over 4 million tons of carbon dioxide emissions compared to equivalent travel in petrol-powered vehicles. The second example is smart mobility solutions by Mercedes-Benz, Intelligence World Drive. So they have developed the Intelligent World Drive, which is an advanced driver assistance system that uses AI, artificial intelligence, and connected vehicle technology to optimize traffic flow and reduce emissions. The third example is urban planning. As I said, London's ultra-low emission zone. London has implemented an ultra-low emission zone to improve air quality and reduce carbon emissions in the city center. Vehicles that don't meet strict emission standards must pay a daily charge to enter the zone. On an average day, 96% of vehicles driving in London now meet the ULEZ emission standards, which is ultra-low emission zone standards, up from just 39% in 2017. So today it's 96%. It's a huge pickup. And number 4, sustainable fuel for cargo transport by Maersk Eco Delivery. The Maersk, the world's largest container shipping company, has introduced its Eco Delivery service, which uses sustainable biofuel to power vessels. Remember, I mentioned in the previous slide that most of the greenhouse gas emissions happen in the maritime sector. So this is a solution. This biofuel is produced from waste cooking oils and can reduce carbon dioxide emissions by 85% compared to standard marine fuel. Maersk has also ordered 19 carbon neutral container vessels powered by green methanol, set to be delivered between 24 and 25 in order to achieve net zero emissions by 2040. Good news. And then we have fifth example, efficient logistics by UPS Orion, on-road integrated optimization and navigation. So they have developed Orion, an advanced route optimization system that uses algorithms to determine the most efficient delivery routes. I will go into the next example, the hydrogen fuel company by Iberdrola. So Iberdrola is developing Europe's largest green hydrogen plant for industrial use in Spain, with a 100 megawatt solar photovoltaic plant, a 20 megawatt hour battery system, and a 20 megawatt electrolyzer. So this facility is expected to produce 3,000 tons of green hydrogen annually, potentially reducing carbon dioxide emissions by up to 48,000 tons per year. And next example is biofuels by Shell, the aviation sustainable aviation, Shell Aviation Sustainable Aviation Fuel. So Shell Aviation is pioneering the SAF production from sustainable feedstocks and can reduce life cycle carbon dioxide emissions by up to 80% compared to conventional jet fuel. So Shell has supplied SAF to airlines at several major airports, including Amsterdam, Schiphol, and San Francisco International. And company aims to produce 2 million tons of SAF per year by 2025, which could potentially reduce aviation emissions by 1.6 million tons of carbon dioxide annually. So these are the great initiatives by these giant companies. And we have public transport, London's zero emission bus fleet. I mentioned about this in the urban planning as well. So we'll go to the next one, synthetic fuels by Porsche e-fuels. Porsche is producing synthetic fuel or e-fuels as a carbon neutral alternative for internal combustion engines using renewable energy, water, and carbon dioxide captured from the air. The company claims that e-fuels can reduce carbon dioxide emissions by up to 85% compared to conventional fuels. And finally, we have cycling infrastructure in Copenhagen, bicycle superhighways. So this is obviously a great initiative which doesn't produce any greenhouse gas. So let us move to 3 more sustainable transport solutions, which is number 1, encourage more carpooling and ride sharing. I think in many of the countries this is happening. I'm not sure whether India is doing this. Carpooling helps people save money on fuel, reduces traffic congestion, and cuts down on carbon emissions, thus ensuring environmental, social, and financial benefits. Carpooling programs like ride-share services tend to only do well in more populated areas because there are fewer ride-share drivers available in rural or suburban areas. I can remember when I visited China, they had a big air pollution problem at that time. So they reduced 2 days of the week. No vehicle can come to the Beijing city. By doing that, they somehow managed to mitigate that air pollution problem. And number 2, greener supply chain transportation. Transportation that serves the purpose of transporting goods for the supply chain by trucks, planes, ships, and trains is responsible for 8% of global greenhouse gas emissions. Without major changes, freight transportation is expected to become the highest carbon emitting sector by 2050. But we talked about the Myers solution for this issue. And of all the, we can skip that, and then we can go to the educate drivers on more sustainable travel. This is a kind of brainwashing exercise. So we have to educate people. We have to give this message more and more on how to travel more sustainably is a key part of an effective sustainable transportation strategy. While it takes time to build sustainable infrastructure, local and national governments should spend time and resources educating and encouraging the population about the environmental impacts of certain means of transport. So with these solutions, I think we will be able to provide better sustainable transport solution. And we will move into number 4, smart cities and sustainable infrastructure. So we talked about smart buildings and sustainable construction, and green building, we talked about it. Let me a little bit of talk about 3D printed buildings. So advances in 3D printing, which is reducing material waste, enabling the construction of more complex, sustainable structures, and even facilitating the construction of affordable housing in remote areas. And also energy efficient building design and modular construction technology. Passive house standards and smart building system that adjust heating, cooling, and lighting based on equipments and weather conditions are reducing energy consumption in building. So this is building management software. Nowadays we have building management software where you can control your buildings, even utilities, utility usage, consumption, everything, even from your office. So this is how today's technology has developed. And smart grids and IoT in energy management. So we discussed about this in the under smart grids, and we will talk about this in my future slides as well. And there are some positive examples of smart and sustainable cities. I have taken 3 examples. One is Smart City Zurich. So Zurich, Switzerland. Zurich started its journey in 2018 with improvements include infrastructure which has been digitized, public transportation, and a smart building management system to regulate energy consumption. And number 2 is Smart City Amsterdam. Amsterdam's embarkation towards a smart, sustainable city began in much before, in 2009, to minimize 40% of carbon emissions by 2025. So both the
Hello, sir. You are not audible.
I want to take a small break for about 3 minutes by showing you another video which is very relevant to this smart.
Yes, no problem. Yeah.
I hope you see the video and hear the voice.
Yes, sir. Yes, we can hear and
Okay, right. Okay, right. Please enjoy the video.
Here are the 10 most futuristic places in the world that you won't believe exist. Number 10, Songdo, South Korea. Songdo is one of the world's first fully smart cities, where nearly everything is connected via the Internet of Things. From garbage disposal to traffic management, the city operates using high-tech automation, making it a model for future urban planning. Songdo's trash system is entirely automated, with waste traveling through underground pneumatic tubes to processing facilities. Number 9, Changi Airport, Singapore. Changi Airport is more than just a transportation hub. It's a futuristic destination featuring the world's tallest indoor waterfall, robot cleaners, and a butterfly garden. It seamlessly integrates nature with technology, making it a model for the airports of tomorrow. The airport is also home to a giant netted playground, complete with slides, suspended bridges, and an air-conditioned forest. Number 8, Masdar City, United Arab Emirates. Masdar City is the UAE's carbon-neutral, fully sustainable city, designed to have zero emissions. It's powered by solar energy and features electric driverless cars for public transportation. But despite its futuristic ambitions, the city still struggles to attract permanent residents due to its desert location and extreme climate. Number 7, the Eden Project, the United Kingdom. This vast eco-project in Cornwall, the UK, features enormous biomes that simulate different ecosystems from around the world. It's an example of futuristic sustainability efforts, showing how human-engineered environments can mimic natural ecosystems. One of the biomes houses the largest indoor rainforest in the world. Number 6. Neom, Saudi Arabia. Neom is a planned futuristic city in Saudi Arabia designed to be powered entirely by renewable energy. It's expected to include flying taxis, an artificial moon, and a glow-in-the-dark beach. One section, called The Line, will be a 170-kilometer linear city with no cars, no streets, and run entirely on AI. Number 5. The Mars Science City, United Arab Emirates. The UAE is building a $140 million Martian city simulation in the desert to test the possibility of life on Mars. The city will replicate Martian living conditions, providing a research base for scientists and engineers. The project includes a museum built from 3D printed sand from the Emirati desert. Number 4. Shenzhen, China. Shenzhen is known as the Silicon Valley of hardware and is pioneering advancements in drone technology, AI, and 5G networks. The city is filled with towering futuristic skyscrapers and smart technology integrated into everyday infrastructure. Shenzhen is home to the world's largest drone manufacturer, DJI, which produces 70% of the world's consumer drones. Number 3. The Hyperloop Test Track, Nevada, USA. The Hyperloop is Elon Musk's vision of the future of transportation, with passenger pods that can travel at speeds over 700 miles per hour in vacuum tubes. The test track in Nevada is the most advanced prototype of this potentially revolutionary system. If fully realized, a Hyperloop trip from Los Angeles to San Francisco could take only 35 minutes. Number 2. Singapore's Supertree Grove, Singapore. Singapore's Supertree Grove is an eco-park featuring massive artificial trees that are covered in plants and provide shade, generate solar power, and collect rainwater. These futuristic structures help cool the surrounding environment while blending nature with technology. Some of the super trees also light up in a synchronized evening show, powered by renewable energy. Number 1. Oslo Airport City, Norway. Oslo Airport City, currently in development, will be the world's first fully sustainable, self-sufficient city powered entirely by renewable energy. This futuristic city will feature autonomous vehicles, green rooftops, and energy-positive buildings.
Okay, are you all with me?
Yes, yes.
Okay, right. So let me continue. So we are into number 5, waste management and circular economy. There are a couple of questions we have to first be clear by ourselves. So what is a circular economy? In a circular economy, production materials are designed to be reused, recycled, recovered, or remade to keep them in the economy for as long as possible. Waste is avoided or minimized. Greenhouse gas emissions are cut as a result, along with unsustainable use of the planet's resources. So this is the definition of what is circular economy. And what is waste to energy technologies? Converting waste into usable energy through processes like anaerobic digestion or gasification is reducing landfill waste and generating power. We recently had a field visit by our Institution of Engineers to a plant, waste to energy plant, and it is amazing that all the waste generated in the Metro Colombo area are collected by this plant and they generate power. Then we have recycling and upcycling innovations. Advances in chemical recycling, which can break down plastics into reusable monomers, helping address the issue of plastic waste in a more sustainable way. And then circular manufacturing. Engineering approaches focus on circularity, designing products for reuse, manufacturing, and repair are reducing the need for virgin materials and minimizing waste. And then finally, we have circular economy in construction. Recycled building materials and sustainable waste management practices are being incorporated into construction projects to reduce resource consumption. So we'll go into details. So you can see the dangerous forecast of solid waste generation unless governments proactively take measures. We do have waste controlling methods like which I mentioned in the previous slide, and I'm sure India is taking very precautious actions on this matter. And you can see in the graph on the screen, 2020, 2030, 2040, 2050. It's drastically increasing. So I think this is just the forecast. By looking at this, governments have taken measures so that in time to come, we will see a different type of graph. And this is waste management and circular economy. You can see various types of waste management have helped, will be helping governments to. This is the global situation. You can see recycle is reducing, waste to energy is reducing, landfill is increasing, but overall there is a reduction, and uncontrolled is by 2050 is going to be zero. So you can see how the world has addressed this waste management and circular economy issue. So this is a good sign. And the heat case for a circular economy in waste. So you can see how it is happening in the environment. The migration of endocrine disrupting chemicals and other pollutants from waste into waterways and the human food chain. So we have to be very serious about this issue, and the environment, especially environment engineers, sustainable engineers should take care of the waste, pollutants, disrupting chemicals, endocrine disrupting chemicals, will not go into the human areas, the soil where we plant our products, and then groundwater table. So all these things have to be very carefully addressed. And then we have waste management and circular economy. This is other way of projecting the same slide 2 slides ago. So you can see 2020 baseline, and then 2050 waste management as usual, if we go as usual, and 2050 waste under control, the third column, right? So if we control it, you can see we can reduce somewhat. And then if we apply circular economy concepts by 2050, how it goes down. So this is a very good analysis of how waste management and circular economy should be controlled. So these are the lessons for our young engineers. If you are working as sustainable engineers, solid waste management engineers, or the green energy engineers, likewise. So these are very good lessons for you to as to how to act. So this is global direct costs of municipal solid waste management in 2050 under the 3 scenarios. And we are moving into the next area, which is agriculture and food security innovations. This is a much talked about subject, especially after the COVID pandemic and the global recession, because the world was of very concern because of the economic difficulties overall globally we had to experience, and also the COVID pandemic has gave us so many lessons. So let us see what are the innovations in agriculture and food security. Number one is precision agriculture. What is precision agriculture? The use of drones and sensors and AI for better soil monitoring, water use, fertilizers, and pest control, leading to reduced resource wastage and increased crop yield. I visited Israel they have only a single lake in their entire country, but one of the top countries who export vegetables and fruits to the Europe. So they are extensively using these technologies in their agriculture. And then we have vertical and urban farming. Innovations like vertical farming and hydroponics are revolutionizing food production, which use less water and land compared to traditional agriculture, reducing transportation costs and carbon footprints, especially in urban areas where arable land is limited. So you can still have your crops planted, even in your balconies, on your rooftop, etc. So using this vertical and urban farming technology. And then we have plant-based and lab-grown meat. This is a new concept. Emerging technologies like lab-grown meat, can you imagine? And plant-based proteins as alternatives to reduce the environmental impact of animal farming, which is a significant source of greenhouse gases. And these are the innovations that will transform food security in detail, right? So vertical farming, I talked about it, and then precision agriculture and data-driven farming. So precision agriculture utilizes cutting-edge technologies like sensors, drones, and AI to gather data on soil health, weather patterns, and crop growth. And then we have aquaponics, the harmony of fish and plants. Since I am working for the fisheries ministry, we are very much concerned on this. Aquaponics, a symbolic system that combines aquaculture, fish farming, with hydroponic soilless plant cultivation. In this innovative setup, fish waste serves as a nutrient source for plants, and the plants in turn purify the water for the fish. The Food and Agriculture Organization of the UN. So we are working very closely with FAO, and we work on all these. Actually, sometimes back, our ministry was combined with the agriculture ministry as well. So this is joint effort. And then 3D printed food, a futuristic feast. Using edible ingredients, food printers can create customized meals with precise nutrient content, shapes, and textures. So we never believed, we never thought something like this will happen in future. I think the audience, the young audience in front of me will experience these new technologies much more than us. And next one is insect farming, bugs on the menu. Insects such as crickets and mealworms are highly nutritious, require minimal space and resources, and produce fewer greenhouse gas emissions compared to conventional livestock. The next area is smart storage solutions, prolonging freshness. Food waste is a significant contributor to global hunger and environmental degradation. Smart storage solutions such as IoT-enabled containers and biodegradable packaging can help extend the shelf life of perishable goods. We even use for the efficient storing of fish when it is trading. We use these technologies. Even let me recall. Okay, the tags using technology for storage. And then we have climate resilient crops adapting to change. With climate changing, intensifying, traditional crops may struggle to adapt to shifting weather patterns and extreme conditions. Climate resilient crops bred through advanced genetic techniques like gene editing can withstand heat, drought, pests, and diseases. And then we have mobile apps for food redistribution. The fighting food waste is mobile apps have revolutionized various aspects of our lives, and now they are being harnessed to tackle food waste and insecurity. Food redistribution apps connect surplus food from restaurants, supermarkets, and households with local charities and food banks. And we have blockchain for transparent supply chains. So we all know how, what are the applications of blockchain technology other than the cryptocurrency. So blockchain technology can be used in supply chains, ensuring the food security also involves understanding the journey of food from farm to fork. Blockchain can create transparent supply chains by recording every step of the food production and distribution process in an immutable ledger. Then finally, we have genetic diversity conservation, preserving seeds for the future. So preserving genetic diversity is critical for maintaining resilient crops and adapting to evolving environmental conditions. Seed banks around the world collect and store diverse plant varieties, safeguarding them from extinction and ensuring a constant supply of genetic material for crop improvement. So these are the innovations that will transform food security. And you can see agriculture and food security innovations, how contribution of biotech crops to food security, sustainability, and climate change solutions. So the slide says everything. I will skip it with the time limitations. And these are the positive impacts of agri-technology in advancing food security. IoT, the power of data analytics and boosting farm productivity. I think we talked similar things previously. And remote sensors, how remote sensors can help in food security insurance. And then crop nutrient management, keeping nutrients on and in the field. Efficient nutrient management planning aims to provide the optimal application of nutrients to meet the individual crop needs, to maximize yields and quality, and minimize the environmental impact. And we have autonomous farming, how it will change the face of agriculture in coming years. Traditional agriculture is changing towards autonomous drones, self-driving tractors, combine harvesters, and even robots that go out autonomously in the fields to plant seeds are expected to become more familiar sights in the near future. So we are talking about so many acres of cultivation, which you can't handle manually. And then precision agriculture, the undeniable advantages it brings to modern farming. So it is farm management strategy that collects, processes, and analyzes data to improve farm profitability, efficiency, and sustainability. It is one of the most effective and common applications of IoT in agriculture, and is set to play a crucial role in advancing food security sustainability. And what are the positive impact of agri-technology in advancing food security? So predictive data analytics in agriculture. This is a transition from big data to smart data. How? With environmental challenges such as climate, sustainability, and increasing pressure feed the growing population, agri-tech solutions can rely on big data analytics to help advance food security, thus enabling new ways to grow more using less. Predictive analytics in agriculture utilizes the analysis of data from events in the past and today to obtain insights accessible beforehand to help predict possible outcomes based on well-informed decisions taken today. And then we have GIS in agriculture. This is a very common use. This is an invaluable tool to the modern farmer through its ability to create and manage visual representations of data, as well as analyze multiple data layers, especially even rainfall. About rainfall, the GIS data can give good predictions. Data generated to a map, GIS performs spatial analysis can integrate location data with descriptive information, providing a real-time foundation for analysis mapping. And then we have finally bioengineering in today's agriculture. So it is another essential means of ensuring that the global population can enjoy access to the necessities that life in the 21st century depends on. The role of bioengineering in agriculture is to provide efficient solutions to the agriculture industry that increase productivity and food safety while reducing waste and protecting natural resources. And we are moving into our next area, smart grids and IoT for sustainability. So since I touched smart grids and IoT, let me skip this slide. But before that, you can see the slide talks about everything. It's a smart grid. You can see power generation, the energy storage, the transmission, the distribution, and consumers. Everything is connected with this smart grid. And this is a digitized, a new way of power handling by utility companies. So you can manage your own power consumption. When the power is over consumed, you can reduce power by you can have your the app on your phone, and if you have your own generation of solar, you have the power generation patterns, how power is generated during hot time, during cool time. Likewise, these smart grids help not only consumers, not only the utility companies, even the engineers who are working in the industry, they all are kind of helped by these smart grids. And these are the key components of IoT in smart grids: the smart meters, sensors, communication network, advanced analytics, and grid automation. So you can see in the graph, it's a smart meter, the utility company. So I don't have to, I think, talk about all this because we have touched these things. Let me only touch the advanced analytics and AI, how with the data collected from various IoT devices, AI and machine learning algorithms can be used to analyze and predict energy demand, optimize energy storage, and even detect faults in the grid before they cause widespread disruptions. And also grid automation. Automation technologies powered by IoT enable the grid to respond to changes without human intervention. For example, in the event of an outage, automated systems can reroute power, minimizing disruption and ensuring a more reliable service. So this is how the automation can help the utility companies to address the issues. And then we have IoT applications in smart energy. The demand response programs. So this is what IoT and AI can help. Key IoT application that helps balance electricity demand and supply using IoT-enabled smart meters and sensors. This is happening. And if I go to energy consumption monitoring and optimization, it is again IoT devices including smart thermostats, lighting systems, and appliances. This enables consumers and businesses to track and optimize their energy consumption. So this is what I previously mentioned. By providing real-time data on usage pattern, these systems can automatically adjust energy settings, reducing waste and improving efficiency. And then predictive maintenance by energy infrastructure. So IoT sensors placed on transformers, circuit breakers, and other critical components of the energy infrastructure continuously monitor the health of the equipment. By using predictive analytics, these sensors can identify early signs of wear and tear or potential failures before they cause significant issues. This leads to preventive maintenance instead of costly emergency repairs. I can remember I was in Rourkela, Indian Institute for Production Management back in 1999, I think some 25 years ago. And I was doing this postgraduate diploma in maintenance management. And I had to do a project. So I selected to measure the heat generation at the high tension power isolators. So that time these technologies were not available. I'm talking about 1999. So they had cameras, thermal cameras. So you take pictures from those thermal cameras and you analyze those pictures from the camera. That's how in 1999 in India I experienced that. Now you see today with the latest additions to this IT technologies, how you can manage it. So it's interesting, isn't it? So, right. So this is what IoT applications. And you can see the two sides, benefits of IoT and the challenges. So of course, improved energy efficiency is a benefit. Then enhance grid reliability and stability, another benefit. And integration of renewable energy, of course. And then, of course, cost savings, right? With the renewable energy, you don't spend on fossil fuels. And then increased consumer control, right? Increased consumer control. So IoT and smart grids can give you all these benefits. While there are challenges, when you use IT systems, the internet usage, the high-end IT systems, you have, of course, cybersecurity risk. And then data privacy concerns. I even heard day before yesterday, the Japanese Airlines was hacked. The Japanese Airlines IT system was hacked. So we have to be very concerned about cybersecurity risk, data privacy concerns, high initial investment, the interoperability issues, the future of IoT in smart grids. So these are very essential areas that we need to be careful. And if you take if I go into high initial investment, the initial cost of implementing IoT in a smart grid can be substantial, right? This includes the cost of installing smart meters, sensors, and communication networks, as well as upgrading existing infrastructure. However, the long-term savings in terms of operational efficiency and energy cost reductions can offset this initial investment. So this is one of the tough decisions the management should take, whether to invest on all these high-end systems, the smart meters, the sensors, IoT, all these, the benefits will come in the long term. So, and also interoperability issues. There could be interoperability issues. So when you have many different types of IoT devices, sensors, and communication protocols on the market, ensuring that all these devices can work together seamlessly in a smart grid environmental requires careful planning and standardization. Without proper interoperability, the grid may become fragmented and inefficient. So this is one of the, this is what you have to do top-down planning. If you go bottom-up planning, you might have interoperability issues because the individual different isolated systems would not apply the open standards. So if you have a top-down approach, you imply that, you impose that ruling that every subsystem should have open standards so that later on when you integrate everything, there won't be any interoperability issues. So this is one of the areas you should be concerned. So we will move into the next area, which is carbon capture, utilization, and storage. This is very important area. You can see the greenhouse emissions sources, manufacturing, the factories, even households, right? And then you capture the carbon dioxide and you compress it, and then you transport it, and some part you store it and some part you utilize, right? So this is the entire life cycle of CCUS. We'll see how it works. What is carbon capture? The CCUS definition. It is carbon capture, utilization, and storage is a term that refers to technologies that capture the greenhouse gas carbon dioxide and utilize it or store it safely underground so that it does not contribute to climate change. And how carbon dioxide is separated and collected. Carbon dioxide is separated and collected from emissions produced by industrial activity, then compressed and transported to a storage site and injected into carefully selected, secure underground geological formation that can safely and permanently store the gas. After injection activity ends at the site is tightly sealed and monitored to ensure there are no safety or health risks to the public or to the environment. So this is what they do. And this is how it happens. The capture, transport, and storage. You can see on the top of the earth, carbon dioxide is being captured, and then it is transported through lines to the underground storage. So capture happens from the gases produced at large industrial facilities such as steel mills, cement plants, petrochemical facilities, coal and gas power plants, or from the atmosphere. So there are several capture methods in use. All are proven and effective with different methods applied based on the emissions source. And how it is transported? As I said, once separated, the carbon dioxide is compressed for transportation. This means increasing pressure so that the carbon dioxide behaves like a liquid. The compressed carbon dioxide is then dehydrated before being sent to the transport system. And how it is stored? Following transport, the carbon dioxide is injected into deep underground rock formations, often at depths of 1 kilometer over, where it is safely and permanently stored. These rock formations are similar to what has held oil and gas underground for millions of years. So this is how it is happening. And number 9, the water purification and management. We all know that water is a main part of our lives. The general consensus is that people can survive for around 3 days without water, with estimates typically ranging from 2 days to a week. There is a general rule of 3, which says a person can live for 3 minutes without air, oxygen, 3 days without water, and 3 weeks without food. So let's explore about water in terms of sustainability. So we having said that the importance of water, we should be concerned about water purification. It is the process where water impurities such as bacteria and microorganisms, organic and inorganic compounds, particulates, dissolved gases are removed from the water, leaving it in a purer state. So why is purifying water important? If source water is used in applications with no modifications to its condition, that can render the results invalid and unusable. So how do you identify the condition of your source water? Not possible through visual inspection alone. A deeper inspection using microbiological analysis is necessary. And these are the two water purification and management technologies. One, Number one is desalination technologies. Number two is smart water management system. So what is desalination technology? It is the advances in energy efficient desalination techniques such as reverse osmosis and forward osmosis. These are providing solutions for water scarcity in many regions around the world. And smart water management systems. You can see in the picture, it is IoT-based systems again that monitor waste, the water usage and quality in real time. This helps identify inefficiencies, leakages, and areas where conservation efforts can. So these are the chemical applications, water purification technology used in medical and chemical applications. So I am just giving you the names of them: activated carbon, ion exchange, electro deionization, pure, reverse osmosis, submicron filtration, and ultra. And this is the process. You can see water purification process, the intake, screening, flocculation and coagulation, disinfection, and then sedimentation, clarifiers, and then precipitation, absorption, filters, disinfection, chlorination, and storage. This is the process of water purification. And we are moving into the final area, which is biotechnology and green chemistry. The climate crisis requires urgent innovation in green technology to reduce emissions. Exciting developments are happening across renewable energy, electric vehicles, battery storage, agriculture, manufacturing, and others. So what is biodegradable plastic? It is bioplastics made from renewable resources such as cornstarch and algae are being developed to replace traditional petroleum-based plastic and reduce pollution. And what is synthetic biology for environmental remediation? It is advances in biotechnology are enabling the development of microorganisms capable of breaking down pollutants in the environment, such as oil spills and plastic waste. So this is the graphical abstract of biotechnology. I will not go into detail with my time limitation. How am I doing with my time, Professor Ravi?
Sir, 5 more minutes we can have.
Okay, right. Okay. So there are some scary data about environmental factors showcased in the forthcoming danger. So I will not go into details, but there are some Earth's temperature has risen by an average of 0.14. The global green technology and sustainability market size was valued at roughly $10.94 billion in 2020, and it will go up to 68.33 by 2028. And greenhouse gas emission decreased from 2019 to 20.9%, largely due to COVID-19. So likewise, there are some factors, some statistics. Since I'm talking to an engineering audience, so these statistics will kind of strike in your minds. And finally, role of Indian engineers in leading global sustainability. I have been working with Indian engineers for last 20 years with my association with the Institute of Engineering and Technology. I even met Professor Ravi Munye in the IIT when I represented Sri Lanka network and he represented Nashik network. So I am very well aware of the capabilities and commitment of Indian engineers. So this is the pinnacle of Indian engineering. The Chandrayaan-3 and Aditya L1. I don't have to explain it, but I take this opportunity to congratulate the Indian engineers for these two massive efforts. So Chandrayaan-3, this was very successful after landing on the moon after USSR, NASA, and Chinese Space Aviation Association. So number 2, Aditya L1, it is the first Indian mission dedicated to observe the sun which was launched abroad. And this is also kind of close to my heart because I was able to experience this while I was in India. We had a South Asia Committee meeting on 2nd September 2023, and the launch happened at 11:50. So we all went to the rooftop of the hotel, and I observed it in my naked eye. So once again, I congratulate all the Indian engineers who have achieved this massive task. And this is my conclusion. So with that, I will encourage the engineering community here to continue driving innovation, collaboration, and sustainable practices. So I do emphasize the need for engineers to think beyond technology and embrace holistic solutions that integrate social, environmental, and economic sustainability. And I want to assure you all that in future, engineering shall lead to a cleaner, greener, and more equitable world with India as a key player in that transformation. The engineering innovations which I presented are not only reshaping industries, but also playing a critical role in mitigating the impacts of climate change, improving resource efficiency, and creating a more sustainable and resilient world. So one last quote, engineering fact. So a long time ago, people who sacrificed their sleep, family, food, laughter, and other joys of life were called saints. Now they are called engineers. So congratulations to all the engineers in the audience. And I wish you all the best. I hope I gave you some information to think. Thank you very much.
Thank you very much, sir, for a wonderful and informative session, starting from Ramayana to engineering and innovations on different sectors using various technologies. Now, Dr. Nandurkar, sir, are you there? Yes. Now I request Dr. K. Nandurkar, sir, Director of the Institute, to say a few words.
Yeah, thank you, madam, for this opportunity. And I would like to thank the speaker today. Sir, you have done a very wonderful job, and you have actually captured the essence of our conference, that was the sustainability issues and the tools regarding sustainability. And you have given so many ideas. I think all the participants will be very much happy to know about this. And probably, as you said in the conclusion, that we should take up this action further. We will definitely take this action further, and we may seek your guidance also in taking the activities further in some of the areas. I was told by Professor Munje that you visited Nashik. I think we could not meet here, but you came to Nashik for IET visit, and that was a great idea to have here. Even we tried to call you here personally so that you could have spoken to the participants, but nevertheless, this was a very good interaction, very interesting talk. I have listened from beginning to the end, starting from Ramayana to this particular conclusion. And I'm sure that people will take it forward. I also got some of the new ideas from this thing, which we can share with the researchers and ask them to do something. Especially, we are working in the field of IoT, sir. I'm from manufacturing field, so IoT applications are going on, and your ideas are really good. We also have agriculture college, so I think some of the agriculture ideas can also be implemented there, and how it can be taken further. And it is really a wake-up call for all the engineers that they have to work on this particular idea of sustainability. And I'm sure our student as well as staffs and all the participants of this conference will take up these ideas and take up the research further, and we can collaborate in future also. So thank you very much for your speech, and thanks a lot.
Thank you, sir. On behalf of the Institute and organizing committee of this international conference, we wholeheartedly thank you for sparing your valuable time, expertise, and knowledge with us. Thank you, sir. Thank you once again.
Thank you very much. Thank you. Thank you for the time. Once again, thank you, Professor Ravi, for inviting me. Yeah. So I wish this conference be a success.
Yes. Thank you, sir.
Thank you, sir.
Thank you.
Thank you.